I have been recently working on a new project, eng-units, on crates.io. This is a work in progress. It is very beta, but it's actually coming along pretty well. And it's going to be a library for building, calculating, and converting engineering units for engineering calculations. So let me show you how that's going to look. So we can create our unit. So we could say let mutable, let's say unit 1 equals engineering unit. And we can construct that from a template. So our template will have a value. So what is the value of the unit? So let's say it's 1.0. And let's use a template of, we could use a base unit like meter. And we can assign it a power 1, which will put it to the power 1 in the numerator. And we can set a label. So we could say 1 meter is the label. This is useful for if you're working on a project and you want to keep track of what is what. And what we can do is we can print U1, and we can say is a unit of, and we can get U1 dot unit name. It can infer what type of unit it is. So let's run this code. So we've created an engineering unit from a meter template with a value of 1.0. And you can see it says 1 meter. This is our label. Is the value 1 meter? Is a unit of length. So it knows that it's a unit of length. And we can create another unit. Let U2 equal eng unit. Let me get rid of this label just because that's a little annoying. And we'll say this is another engineering unit from, and we'll say, let's say from 2.0, and the unit here will be seconds. And the power, let's do -2. So -2 means it'll be seconds squared in the denominator. So let me print U2. So you can see we have now our first unit, 1 meter, it's a unit of length. And our second unit was printed, it's 2, and this is 1 over seconds squared. So it's seconds squared in the denominator. And we can take these units and we can multiply them together because we cannot add them or subtract them because they do not have the same fundamental dimensionality. You cannot add a meter to a second, but we can multiply them together. So we have U1 times equals U2. And let's move this statement down. We'll just print out this one here. So we're going to print out U1 again, and we're going to get the name. Let's see what we get. And now we have 2 meters per second squared, and it says is a unit of acceleration. So it was able to take a meter, multiply it times a second to the -2 power. It's able to do that conversion, and it's also able to tell you that it's a unit of acceleration. Now, what if we wanted to convert that from meters per second squared to feet per second squared? We can say U1 dot change unit. So we're going to inform this that we want to change one of the units, and we have to tell it which unit we want to use. So we would say unit foot. So this will convert all of the length-based items in there, in our case meter. It would convert those to foot automatically. We'll adjust the value. And let's move this down. So we're going to print U1 after changing it to feet. And you can see now that we have 6.56 feet per second squared, and that's a unit of acceleration. And we could do the same with the denominator. So we could say U1 dot change unit, and we could say instead of second squared, we could change it to minutes, although that would be a strange unit, but just for example. So now we have 23,622 feet per minute squared. And it knows that's a unit of acceleration since it's still a fundamental length over time to the power 2. That's a fundamental acceleration. And we can also build units from more advanced templates. So we could say Newton, for example. So let's print this out. So we now have U1 is a unit of, and we'll say U1.name. And let's run this code. And you can see we have 1, and this is the definition of a Newton is kilogram meter per second squared, and it's a unit of force. And we can take that and we can multiply that with a distance, force times distance. So let's do from unit, and we can say 2.78 or 2.85, and we can do something different. We'll say unit, we can do centimeter, and we'll do that in the numerator. And we can say U1 times equals U2. And you can see that yields 0.285 kilogram meter squared per second squared, and that is a unit of energy.